So let's begin with the new lessons. So this is one of the most difficult one, if not one of the most difficult one also. Okay, I'm just repeating myself. So the topic is called rotational kinematics. Do you still remember what just happened from the first semester? So these are the kinematic equations that we have had, or we have used before. At least you should be familiar with these three different equations. So let's go back to what it is. That's final velocity, initial velocity, that's acceleration, and that's displacement. So three different equations. I'm actually writing it down to make it as obvious as possible, because we want to make sure that we understand what's going on. So this one is actually the same term as that one, which is velocity. So when you see this omega looking thing, that's velocity. This is initial, this is final, square. This one, that this thing's looking thing is actually acceleration. This is the displacement. So these are the three different equations that you should be very familiar with at this point. Here, these are the terms. So we call angular velocity, angular acceleration, displacement. Because if it is in a rotational motion, so we call angular. This is a visual representation of what it is. When the object rotates from here to here, we call that displacement or data. It has a velocity. At every single point, it has its own velocity and acceleration involved. Because if the motion itself is not, it doesn't have acceleration, or it remains with the same angular velocity, there should be no acceleration. But if it is not, if the velocity changes, either slows it down or speeds it up, then it will have the angular accelerations. So let's get back over here to see what's going on. So we're gonna go ahead and utilize the concept that we just did understand, or at least mention about three different equations to figure out what the problem is looking for. This one right here, this is a skate, figure skate begins spinning at angular speed of that. So that being the case, so we know for sure that this one right here is equal to 4 pi radius per second. And at the end of that spin, she gains the speed, which is the twice, just 8 pi radius per second. We need to be looking for the angular acceleration, which is that one. Do we know the time? Let me look. Okay, we know time, which is 3 seconds. So now the question is, which equation should we be able to use to figure out what this is? So just look back at three different equations that we have. 1, 2, 3. Both three of these equations has certain thing. Let's look at what we have. This one, do we have this lambda? Do we have this displacement? The answer is no. So therefore, we get rid of this equation to begin with. Look at this second equation. Do we have these two terms? We have that. So that would be the easiest one, because this one also we don't have that term. So we cannot use these two. We must use this one only. So I'm just going to go ahead and write down the equation on a separate color. So at this point, I want you to go ahead and try to at least attempting to solve the question yourself. Because at this point, all we have to do is just plug in numbers. So I'm just going to go ahead and write out the equation. So we're using this one plus this one. Okay. We are solving for this one. I'm just going to go ahead and rearrange the equation. Just go ahead. I'm not rearranging anything. I'm just going to substitute these values. So what do we know? It's 8 pi radius per second. Okay. What do we do over here? That's 4 pi radius per second plus this term. So do we know the time? 3 seconds. So now I'm trying to solve for this one. I'm just gonna go ahead and combine the term. This one, and this one. So it would be only 4 pi radius per seconds. And I have 3 this. Radius per second square. So this is the answer. The answer is 4/3 pi radius per second square. So now we're gonna have to look at how many rotations does it spin. We're gonna have to figure out how long, an object is actually spinning first, and then we divide it by 2 pi r in order for us to get how many spin or how many rotation, did she spin, that she spent. I'm just gonna let you absorb this one for now, and then we're gonna figure out what equation should we be able to use to figure out that spinning rotation thing, okay? So when I try to convert this one, I get about 4.2 radius per second square. So we're gonna use this one in order for us to calculate this. So we know this one, we know this term. Do we know this term? Now we do. We know this term, we just calculated that. We figured out that. So I'm just gonna utilize that equation. So now I'm just gonna substitute the values in. This is 4. Ngay cả nhé. Ủa đi, nhiều. Okay, what is our initial, which is 4 pi radius per second? And do we know the time? Yes, it's 3 seconds. Plus this one, 1/2. This one is actually 4.2 radius per second square. Time is 3 square. So when you compute this one, what number should you get? .59 radians. And you're gonna have to combine the term to figure out what it is. So in order for us to calculate how many rotations the should spin, we're gonna have to divide. This is the unit conversions, okay? We're gonna have to divide by 2 pi radius. And when you do that one, you divide your numbers that you have by 2 pi radius. 2 pi radians. So basically you divide that by 2 pi. And the answer you should get is about exactly 9 rotations. That's how you get the answer. So now go ahead and come back here for the second equations. We're gonna go ahead and solve the second board right away. What is the real final angular velocity? So basically we are looking for that one. We don't know that. That's what we're looking for. That's based on the question only. And now you're gonna go ahead and look at to see what else is given. We know this one is actually 10.8 radian per seconds. So this one for this angular motions, or the what is it? Rotation kinematics. We only use radian. We don't use the angle anymore. Those two, and look at what else do we have? Acceleration. We also have this 2.4 second square. So basically we get this this one. Do we know the term? we don't know because that's what we're looking for the next one. So this equation, you're gonna go ahead and look back at the equations. So go back at 3 different equations that you have. You see what else you have. You have the acceleration, you have the initial velocity. Do you know the time? You don't know the time, then therefore you cannot really use those 2 terms. So let's go back to the first one to see what we have. Eventually the car, look at the equation to see what else you have. So the question is says that, the car is actually comes to rest after 3 different rotations. So you're gonna have to utilize what you have right here to figure out. So it's 3 rotations. So you're gonna have to use 3 multiplied by 2 pi radian. And that should give you about, let's look at use the calculator to calculate the thing, the values. So the answer is 18.85 radian. That is actually